Hi, welcome back. So last time we had really hammered home the idea that vectors, both atomic and non-atomic, are ordered collections of elements, and because they are ordered, the elements themselves can be accessed by their position. Okay, and we said that this is very important for us to understand as far as functional iteration, and the reason why is because the iteration part of functional iteration requires us to have ordered information. So if I'm going to iterate from one thing to the next, those things need to be ordered. So the functional part of functional iteration means that we need to have functions. So if you remember, this was one of our we talked about this in the previous lesson. Functions. So functions have a name in the global environment. Functions have arguments, and that's the stuff that lives inside of the parentheses. And then functions have a body. And so this is an expression of our code. And this expression lives in between an open curly brace and a closed curly brace. And we said that a function will return to the global environment or whatever environment called it the last computation that the function does. Now notice here, there's a lot of lines here, but this is all wrapped inside of one function, and that is this concatenate function. So technically speaking, even though this function does a lot of different computation, the last line is this entire thing right here. So this function is basically just doing one thing, and that is to create a new summary of the data, a 7-number summary of the data with including the mean, or is this 8-number? Yeah, this is an 8-number summary of the data that includes all of the quantiles, but also the standard deviation, the interquartile range, and the mean. And so we say, okay, well, we've got our data summary function. And so the next thing we do is we have a test of this function, okay? So as an exercise, I want you to go through this. I want you to find the name. I want you to find the arguments. I want you to find the body. And then I want you to think about like, well, what happens if there are missing values in X num? What would you have to do to the arguments and also to the body? So the arguments and the body of that function to modify the numeric summary function to remove those missing values. And finally, one of the other things that we had said in the last lesson was that functions should absolutely have documentation. So I want you to sketch out some documentation for this function as well. All right, so we're going to take a pause here and we'll pick back up. So basically this is our review of functions. So last time, in the last video, we talked about a review of vectors and ordered collection of objects. This is a review of functions. Functions have arguments, they have a body, and they have a name. And we'll pick back up. Next time we'll learn about, after you come back from these exercises, we're going to learn about functionals. All right, so we're going to pause here. All right, so you've had a few minutes to work on these exercises, and so now we'll work on, we'll learn about what a functional is. So far, in this semester, we've called a lot of R functions. So there's the old adage that everything in R is an object, and then the complementary adage is basically everything R does uses a function. So if there's some action that is taken in R, it's going to use a function. And a lot of times we've interacted with functions in this way right here, where we say, okay, well, here's the name of a function, and we've supplied this input, we've supplied this other input, and we've supplied some more arguments or some more options or whatever for how this function is going to do its computation. And then here's the output, okay? So this is like the direct, like calling a function directly, all right? Now, functionals allow us to abstract this relationship. And functionals are built on the idea that functions themselves are verbs. And if they are verbs, you can command R to do the action in that verb. You can say, do this function, okay? So the functional form of a functional would be to say, all right, I want you to do something, and the something would be this. So do to these arguments this function with these options. All right, another way that we could write a functional form is to say, do this function to these arguments with these options, okay? And then either way, we're saving the output over here. Now, this this may look kind of simple to you, but in the abstract, this is an incredibly powerful approach to writing functions, okay? Because what it allows us to do is it allows us to say, all right, well, normally we've had, like, let's say I want to take the average of something. I mean, here's what you could do. You could think about using group by and summarize way back in the dplyr lecture. And what it was doing is you were saying, all right, I want to group the data. I want to separate the data into these groups. And within each group, I want you to take the mean of, I don't know, age, or the mean of the blood pressure or something. Technically speaking, what you're doing is you're applying a functional, okay? And so that's this example right here. We've actually seen something very similar to a functional already. And we say, all right, I want you to break up the data into these groups, but then I want you to summarize. So I want you to do something. So do, i.e. summarize, but what do you want me to do? I want you to do this. I want you to find the maximum. But what do I want you to do it to? I want you to do it to each of the countries. Okay, so we're saying do to each of the countries. That's the group by part. So group by says to the countries. So do to each of the countries this function. Well, what's the function? The function is find the max. And then with this option, the option being remove the missing values. Okay, or if we do it the other way, we say do to this function, i.e. find the maximum. So here's the do command. So sorry, right here, summarize, do this command, find the max, to what? Well, to the countries with this option. So right here, with this option. All right. So even though we're seeing it in the abstract up here, the idea of like, okay, so do to these inputs this function with these options. We've actually already done stuff like this, and that is the group by and summarize. We say, okay, well, this is the two. So there's a whole bunch of countries that I want to perform this operation on, and the operation on is find the maximum of the life expectancy, and the option is I want you to remove missing values. So we see that we've done something like this before. All right, so this is the way that the summarizes. If I rewrote this code to look like this, then it would be down here. So do to the life expectancy, the function is take the maximum with the options of NARM as true. And that would be with the life expectancy within each country. So this would be life expectancy for country 1, life expectancy for country 2, life expectancy for country 3, life expectancy for country 4, life expectancy for country 5, et cetera, et cetera, et cetera, et cetera. So this right here, life expectancy, this isn't just one thing, but it's actually an ordered set of values. So I've got the life expectancy for Sierra Leone. Then I've got the life expectancy for Angola. Then I've got the life expectancy for Afghanistan. And I've got the life expectancy for Liberia. And so each one is an ordered set of values. And to that ordered set of values, so in the first one, whatever that is, I want to find the maximum with the option of NARM is true. All right, so that's, yeah. I've got this called out right here. Functionals are functions that take in another function as one of its arguments. Okay, so let's think about that for just a second. So we're thinking about this and we're saying, all right, imagine that you're giving a set of commands to, I don't know, maybe you have younger siblings or something like that, and you're working with your younger siblings to prepare food for one of the holidays, okay? And you have a command. You say, you need to do this, whatever the this is. The this may be perhaps peel a potato. Okay, so peel, all right? Because you're going to make, I don't know, you're going to make some potato pasta or potato bread. So the overall process is we need to peel potatoes and we need to boil them and then we need to smash them and then turn them into the bread or the stuffing or whatever it is. But the point is that you're going to say, all right, I need to peel a potato. Okay. So there's a couple of ways that you can apply this. You can invoke or do this command. If you have 5 siblings, you can assign each sibling to get their own potato. So I've got 5 potatoes and 5 siblings. So I'm going to hand a potato to each sibling, and I'm going to tell each of them, do the peeling command. Like, do this. So I've got the this part. The this is peel the potato. Okay. And the two would be to this potato, to this potato, to this potato, to this potato, to this potato. So I've got 5 potatoes. And so I'm going to each of my siblings and I'm saying, each one of you peel 1 potato. Or I could do it another way where the command is the same, the peel is the same, but I'm just telling myself, okay, self, you need to peel these 5 potatoes. So do this first to this potato, then put that potato down, then this potato, peel it, then put it down, then this potato, peel it, put it down, then this potato, peel it, put it down, then this potato, peel it, put it down. So the action of doing this, what we're doing, the action doesn't change. The action is peel 1 potato, but which potato gets peeled will change every single time. Sometimes you can say, who is peeling the potatoes? You can say, okay, well, this sibling is peeling 1 potato, or this sibling is peeling a potato, that sibling is peeling a potato. So the two and the options could change, but the action that's being done is basically the same every single time. But you are giving the command is not peel, the command is, hey, you go get that potato and peel it. Okay. Now, if there was only one person and only 1 potato, you could say peel. And they would be like, okay, well, I know I need to peel this potato. But if there's a collection of potatoes, or maybe a collection of people, you can't just say, give the command peel. You need to assign the work. You need to distribute the work out. And that's what this functional helper is doing. It's helping you to distribute the work. Okay. Now, why this would be important is, up to this point, whenever we've been doing actions that take a lot, we're saying, okay, well, we can go back to the example of, I've got the numbers from 1 to 10, the atomic vectors, the atomic integer vector from 1 to 10, and I want to add 1 to it. Up to this point, we've been telling R, okay, take this vector and you just add 1 to every single one of these things and give me the new vector that goes from 2 to 11. So that's just basically one action because R is vectorized. However, there are some actions where you can't do that. And you may actually want to split up the work over multiple different computers because the action is so complex that it's taking up all of the resources. The computer has to spend all of its time just thinking about one part, like peeling this potato is so incredibly challenging that I cannot think about peeling any other potatoes. I must peel this 1 potato. Okay. And that whenever we write code in this way, in this functional way, what it can allow us to do is break up the tasks over multiple different computers. That's not something we're going to spend a whole lot of time talking about this semester, but it is something that you could learn about in the future. All right, next time we will talk about exactly that, and that is applying functions to vectors. So see you soon.